Welcome to part 2 of the absolute value graphing transformations, unit 6 of Algebra 1-2. Today we're going to be graphing absolute value equations from Algebra 1, Semester 1. You might recognize the two graphs below. This one is the parent graph for y equals x, which is our linear straight line. That's because x is to the first power. Anytime you see x to the first power, it's a linear equation. This side, if you remember right, is the absolute value, because as x goes into negative numbers, the answer is still positive because it's in the absolute values. So that's an absolute value equation. Absolute value equations are always V-shaped. Isn't it nice that it says absolute value and gives you a V right there to think of? So the first equation, we would actually take the equation given and we would plug in the points. So we're given an absolute value with a negative out in front. So negative absolute value of negative 2. Absolute value of negative 2, distance from 0 is 2, and then multiplied by a negative 1 is negative 2. Negative absolute value of negative 1. Absolute value of negative 1 is 1. Times a negative is negative 1. Absolute value of 0 is 0 times a negative is 0. There's no negative or positive with 0. Negative times absolute value of 1. Absolute value of 1 is 1 times a negative is negative 1. Absolute value of 2 is 2 times a negative is negative 2. So right next to this, I want you to write the points that you're going to graph: negative 2, negative 2, negative 1, negative 1, 0, 0, 1, negative 1, 2, negative 2. Now we plot those points. Remember, this is always your x, this is your y, this is your x, and this is your y. So we go over from the origin, negative 2 on the x, then we go down to negative 2 on the y. From the origin, we go to negative 1 on the x, down to negative 1 on the y. 0, 0, 1, negative 1, 2, negative 2. Now we connect our points with the straight edge. Please always use a straight edge in class. What we're looking at is what change happened when we put this negative inside of that parent function. The parent function was a V like this, but when we changed it by putting a negative out in front, what happened to that parent function? If you're saying that it reflected, that would be the shift that occurred, or the transformation. Shift is reflection. Absolute values are always V-shaped. Another equation here. Take the equation I give you. Take the equation I give you. Put it in the table. Plug values in. Remember, you have to solve the absolute first because it's a form of parentheses. That's order of operations. So the absolute value of negative 2 is 2 times 4 is 8. Absolute value of negative 1 is 1 times 4 is 4. Absolute value of 0 is 0 times 4 is 0. Absolute value of 1 times 4 is 4. Absolute value of 2 times 4 is 8. So we see that we're at 0. At 1 we come up to 4. And at at 2 we come up to 8. So if we draw that line, and compare it to the parent graph, we notice it gets real skinny. We say in math that you're stretching it away from this x-axis. See how the parent graph came out like this? Well, you've stretched the top of this graph a lot further from that. So we say it's stretched by a factor of 4. Don't know if you noticed there, but on the parent graph, you come from the origin, go up 1 over 1. On the new stretch graph, you go up 4 and over 1. That's really like a whole new slope having that a value in front of there. Now we have a -1/2. Well, we know that the negative turned it upside down. We know that the 4 caused it to be real steep. So stop the video and think for a minute. What do you think the 0.5 will do? Now we take -1/2 times the absolute value of -4. -4, absolute value is +4. Half of that is 2, and then multiply by the negative, so -2. Absolute value of -2 is 2. Half of that is 1, times the negative is -1. Absolute value of 0 times the -1/2. Anything times 0 is 0. Absolute value of 2 is 2, times the -1/2 is -1. Absolute value of 4 is 2, times the -1/2. Absolute value of 4 is 4, times 1/2 is 2, times a negative is -2. Sorry about that. Okay, so we write our points. -4, -2, -2, -1, 0, 0, 2, -1, and 4, -2. Now we plot those points. At -4, it's -2. At -2, it's -1, 0, 0. +2, it's 1. And +4, it's 2. We bring in a straight edge to complete that line, and we see that we've taken that parent graph and we've gotten it real wide now. How before we said that that 4x caused it to stretch, now we say it shrinks. So it shrinks by 1/2. The next graph, you will plug in the value and then subtract. So we have absolute value -2 is 2 minus 1 is 1. Absolute value of -1 is 1 minus 1 is 0. Absolute value of 0 is 0 minus 1 is minus 1. Absolute value of 1 is 1 minus 1 is 0. Absolute value of 2 is 2 minus 1 is 1. So when we graph this, we come over and we go to the x value, it's -2. We go up to 1. We go -1 and we don't go up at all. Then we go neither left nor right, it's 0, and we drop to -1. We go right to 1 and 0, and over at 2 it's at 1. So we see this time that we took that parent graph and we didn't make it skinny or wide, but the parent graph, remember, started at 0, 0 up here. So we took that parent graph and we shifted it down 1. So we say the shift is down 1. You can predict what this would do, then go ahead and fill in the table and see if it shifts the way you think. The next one, we have the value inside the absolute value. So we have x minus 1, the absolute value of -2 minus 1. We actually have to work that out before we bring it out of the absolute values. So -2 minus 1 is -3. Absolute value of -3 is 3. -1 minus 1 is -2. Absolute value of -2 is 2. 0 minus 1 is -1. Absolute value of -1 is 1. Go ahead and plot those points, and we will do more when we get into class. I think that I'm running out of tape.